Welcome to the IoT podcast. Today I'm joined by not one, but two executive pioneers in the IoT space. Firstly, we're joined by James Thomason from EDJX, and secondly, from Jeffery DeCoux from the Autonomy Institute. Thank you both very much, gentlemen, for joining us today. Could you start by just introducing yourselves and your background within your respective businesses? Jeff, perhaps you can kick off.
Oh, yeah, sure. So Jeffery DeCoux, the Autonomy Institute, my background is over 30 years in enterprise software, taking new technology innovations and bringing it to market. And now focused on autonomy, which puts us front and center on how IoT can be densely populated.
Fantastic, thank you. And James, how about yourself?
I'm James Thomason. I'm CTO and co-founder of EDJX. I've been in the tech space in Silicon Valley for about 20 years, building early stage startup companies and selling them and taking them public. That's what I do.
All right, fantastic. And just to explain a little bit more about the two businesses, so obviously working together at the moment, but Jeff, could you give us a bit more detail about the Autonomy Institute and your relationship with EDJX?
Yeah, there's a long history, but the really short story is the Autonomy Institute is a 501c3. It was stood up about a little over 2 years ago, primarily to focus on getting the infrastructure, the digital infrastructure, densely populated within cities, states, and down highways, to enable all these Industry 4.0 applications that we're all excited about, but require a densification of not only networking, but also compute and sensors and things like 5G. The relationship we have with EDJX is once we understood the densification and developed a concept we'll talk about today called PINN, the Public Infrastructure Network Node, the realization of a new software platform or a new development platform came about, and that's when we were able to discover EDJX as having a new environment that was really ideally suited and really designed from ground up to take on these new applications that will be at the edge.
Yeah, fantastic. And obviously, James, relationship growing obviously with the Autonomy Institute, but a bit more about EDJX and its beginnings as a business, if you could.
Absolutely. So we're a startup company. We're about 2 years old now. And what we are is an edge computing platform that makes it easy to write and develop IoT applications using serverless computing, accelerate content delivery at the far edge of the network, and increase the responsiveness of edge applications and secure edge data right at the source. So in a nutshell, we help businesses handle the explosive demand for data processing at the edge to serve real-world edge computing applications, including industrial IoT, artificial intelligence, augmented reality, robotics, and your standard run-of-the-mill web applications and mobile apps that you want to accelerate closer to users.
Okay, fantastic. And Jeff, you mentioned it just within your introduction there about PINN. So for people that aren't aware, Public Infrastructure Node Initiative. You're literally announcing this any moment now. Could you explain a bit more about that?
Yeah, absolutely. And I think it was a long journey to get to where the PINN became a new standard. But the short story is, we were in previous companies looking to get connected and autonomous systems deployed in the real world. We quickly realized that a densification of sensor, of compute, and resilient networks were going to be required to make that happen. We worked extensively with organizations like Crown Castle, American Tower, and the carriers, and then also a lot of the edge compute providers, to understand how can they help solve the densification of the technology. What that led to is the realization that these sensors really had to be populated on curbs, on sidewalks, or in easements that are primarily owned by either cities or states or other municipalities. And in that discovery, we realized that in order to get this deployed, a kind of a new approach at how this technology gets deployed and managed and upgraded over time had to take place. And that's where the new standard, the way we kind of picture it is one of the gentlemen from a very large compute company said, it's kind of like if you were to take a 19-inch rack out of the data center and drop it on the sidewalk, what would that look like? And that's what became the PINN. So it does not look like a 19-inch rack. So let me be very, very straight. It looks to a lot of people like a smart pole. Many people have seen smart poles in the past. But what's unique about it is it's more of a condo. It's a new asset class that basically allows technology to be implemented, but it's not being prescriptive of technology if it's installed empty. So with that, it's opened up the doors to collaborate with cities, with states, with the federal government. And it's now become as fundamental as when Eisenhower finally just said, hey, we need to build interstate highways. It's now that the reality struck people that we have to build this in order to accommodate all this densification. Because it's not just about 5G, which everybody focuses on 5G. That's only 1/5 of the equation. I mean, you have things like assured position, navigation, and timing that has to be densely populated. You have edge compute requirements for densely populated. And you have things like ITS, intelligent transportation systems, already have a lot of compute and sensors at intersections. That's only going to be compounded to be much, much more. So hopefully that'll give you a good overview.
Yeah, absolutely. I think from my perspective, I've got many friends that work in architecture and city landscapes, right? And if we look at the city now, with the onset of the pandemic and the change of the use cases of a city, right? Offices potentially not being in the city, retail not being where it was. In order to harness this technology and use it in a deployable way, it needs to flow with the edges and curves of a city and how it works, right? And it's a really interesting initiative. And it sounds so simple now you say it, right? And now you're talking about it. It's like, well, of course we need that. But it's not until you're actually kind of architecting this solution do you get to that point. James, if you could talk about just a little bit about who's actually involved with PINN, if you could.
Sure. So of course we have the Autonomy Institute itself, but together there's a federation of companies that are working together towards this objective of making access to sensors and computing ubiquitous across the smart cities landscape and other places as well. And the two primaries right now are Atrius Industries, which is a market leader in developing these autonomous applications. And we've partnered with Atrius right now and during the alpha to deliver this ubiquitous computing platform. And so it's EDJX and Atrius and a host of other companies that are coming in that are technology innovators like HP, Cisco, NVIDIA, Vertiv, and others who are contributing their technology to bring this next generation digital infrastructure into full operation.
Yeah, fantastic. I mean, it's lovely to see a collaborative result there with lots of different people getting involved, right?
It takes a
village. I think that's needed. Yeah.
Yeah. At the edge, you need to have the Vertiv to kind of help with the management of the power and the thermal. You need to have the HP that can provide the resilient compute. Then you have obviously NVIDIA with all the different types of advanced GPU for the AI applications at the edge. There's a lot of there's over 70 partners that are directly involved with the Autonomy Institute, and pretty much all of them have some part of deployment within a PINN solution.
Yeah, oh, fantastic. And gentlemen, I mean, you could both answer this obviously together. What are the short-term goals with PINN, and then where do you see this long-terms and perhaps some use cases around it?
Well, I'll talk about from my perspective. It's just build it. I mean, so our entire focus right now is getting the initial PINNs deployed at Camp Maybury. So the goal is to have between 21 and 34 PINNs deployed at the state's facility here in Austin, Texas, and then expand that to what is called SH, State Highway 130, and then quite a few different locations across Austin. Then we're working with Pittsburgh, Raleigh, North Carolina, and about 9 other cities now. With that deployment, it allows the activation of the compute and the sensors and all the 5G equipment. that then allows us to start iterating and building the critical applications at the edge. And that's where, once the pins are in, the EDJX platform and all these services can be activated, and we can start to see all these vibrant new solutions being built.
Fantastic. And in terms of the longer term goals, where could this be, in 5 years' time, in 10 years' time? What types of things can the everyday man on the street see with PINN initiatives, Jeff?
Well, from our standpoint, so the 5-year plan, just to let you know that we're pushing very hard with the U.S. government to basically do an all-out Digital Commerce Act. Our goal is to have a build-out of having all the highways, all the cities, covered with the pins to basically activate the 21st century or Industry 4.0 across America. We're talking about hundreds of thousands of pins being deployed, and luckily there is tremendous amount of money, capital from private investors that want to underwrite that. Once that's there, and to tell you our end goal is, of course, to do connected and autonomous systems and use these resilient platforms to start adding additional city services. But for the first 18 months, it's primarily going to be doing very basic services. It's going to be finally delivering broadband to the home and allowing people, that have kids at home doing homework to have a resilient network. It's going to, allow transportation systems to optimize traffic and get better assessments of what's going on in the city. So as much as, Autonomy Institute is about the future of all these connected and autonomous systems, the pins are going to first really address, core necessary needs that communities have all over the U.S., but of course, much more abroad as well.
Yeah, absolutely. And I think that's the future, isn't it? Rolling this out probably outside of the US as well, and using this as an overall solution to some of these here and now problems that you talk about. James, from your side and EDJX, what is the role that EDJX and edge computing will play within PINN?
Well, first I'll just say that, my colleague is very modest. And one of the things that really stuck out for me when I first met Jeff was that he had this vision of edge computing that was different than pretty much everyone else, except for maybe EDJX, which, a lot of people think that edge is a isolated deployment of, compute attached to some sensor, or it's something that lives behind your firewall. And what Jeff really saw was that, no, that's not the way the world's going to be. Computing needs to become a ubiquitous utility, and there needs to be close proximal computing, tens or hundreds of feet away from users at all times, so that you can really get the high bandwidth and low latency benefits to the next generation of applications. And that was something that we unanimously agreed right away. We have found our partner, because that is the vision of EDJX. And what we do is provide the platform that developers can write applications on and build decentralized, fully distributed and decentralized applications and persist data right at the edge. So you can think of EDJX as a kind of cloud that lives a lot closer. We like to joke that it's, a lot of people say it's fog, it's a cloud that's lower to the ground. But it really is quite different, because the nature of fog computing, the nature of edge computing is different than the tools and technologies that we built for the cloud. And that's what we found right away, is that we had to sort of reinvent the architecture of the cloud to adapt it to this environment where you have tens of thousands of locations spread across the surface of the planet. And you can think, well, I'll just do that with Kubernetes. But when you get down to the brass tacks, if you will, of trying to run 10,000 Kubernetes pods with Helm charts, et cetera, like it's unbelievable complexity. And the other side of that, of course, is making it easy for developers to write applications that can run anywhere and everywhere, and really leverage the availability of proximal computing resources. And once you do that, you can start to open up the possibilities of the different types of applications that you can create when you can rely on computing to be there, right? And that's, we kind of, it's interesting because we kind of take for granted in the cloud capacity. Some people say we've given up the last 5 years of Moore's law in computing just because we could just add more servers, in a hyperscale data center. But the edge is a really resource constrained place, right? And so if you want computing to be available at a moment's notice, to service a request of an IoT device or an end user application, you really have to change the architecture to do that. And so the use cases that are leading this are things like connected and autonomous vehicles, of course, which is one of the major initiatives across the United States. And in the United States, 40,000 people die every year or are severely injured in traffic-related fatalities annually. And so the Autonomy Institute is aligned with the aspirations of Vision Zero and committed to the goal of eliminating all traffic fatalities and severe injuries while increasing the safe and healthy and equitable mobility for all. Try to say that 3 times fast.
Yeah.
And achieving those ambitions really depends on developing new data processing solutions that can connect and combine these and fuse these different data sources. So in a PINN, you will have cameras that are doing real-time video, thermal, radar, LiDAR, other types of sensors that are looking at and detecting the traffic from cars, trucks, bicycles, pedestrians, other things in the local coordinate system in that space, right? And at the same time, you have users and devices which are waking up and sending data. And so this idea of being able to look sort of horizontally across all those sources of data and fuse them in real time in order to make better decisions and to conduct changes in the actual environment is the big idea. And the latency today from street level to the public cloud exceeds 100 milliseconds. And in the future, ITS is going to require unprecedented low latency, high performance computers with GPUs, network, high performance network capacity, interconnected in close proximity to all of this infrastructure that already exists in the city. And so you have, in a lot of ways, the traffic industry in ITS has been the edge, for a long time, and the signaling and sensors and stuff that they have is locked away inside these traffic cabinets and inside of intersections. And so today you can't get access to that data. And so what we think is going to happen over the next 5 to 10 years is that cities are going to wake up to the realization that they are sitting on a vast oil reserve that they can monetize, and it's called data. And there's all sorts of data about city and municipal infrastructure that can be fused together in a platform. And if we create that platform and enable developers to gain access to the data and work with it and build the next state-of-the-art applications to use it, it's analogous to what happened in the cloud, right? In the cloud, you used to have, before the cloud, you had just bunches of servers and networking and this arcane knowledge that it took to use all of that stuff. And what the cloud really did is it made it programmable. Right, so any developer could take advantage of these vast hardware resources in these hyperscale data centers and could count on the reliability, availability, and performance of that infrastructure to deliver their apps. And so we want to do exactly the same thing, but in this really weird place we call the edge. I call it the era of weird-looking data centers. Every PINN is a data center. Every car driving around is potentially a data center, right? And so what you need is this fluid platform that enables developers to have their code emerge and work with things in real time. And it really is like, for the first time in history, computing is moving out of the realm of the abstract, like spreadsheets and browsers and games and the stuff that we did as nerds as kids, and into the real world. It's driving our cars, it's operating pumps and heavy machinery, directing traffic in the city, ventilating buildings during a fire. It's doing all these things in the real world now. And to make that transition requires this ubiquitous layer.
Yeah, I mean, thank you so much for that, James. Yeah, I mean, Mark Getty famously said, oil was the IP of the 21st century, but when we talk of data, this is the next gold rush, isn't it? You talk about a car, having its own data center and the sheer amount of data that can be used and manipulated and understood that you have just within one city is astronomical. You sort of answered my next question there, actually, about the unique angle that EDJX actually has on sort of edge computing and cloud services, etc. So, what is it that you think that people haven't really thought about before that you guys have, and is kind of your USP as a business?
It really is about making the platform a fully distributed system. And so what we are, the way that our platform works is just fundamentally different. It's all peer-to-peer. It's ad hoc, and so it's designed for this opportunistic dissemination of data. In the cloud, it isn't like your racks in your data center, your cabinets grow legs and then walk away somewhere and then show up in another data center later. But that really is a thing, in the far edge where you want to opportunistically take advantage of computing resources when they're available, and you want to match that with demand that is also transient, right? So it isn't like today's world where you are just going to stand up a bunch of virtual machines on some infrastructure or containers on some infrastructure and wait for traffic to happen, right? Or even try to schedule that, because the demand is instantaneous, right? It's instantaneous and dynamic, and so that's quite a different architecture where. At a moment's notice, let's say that an MQTT message comes into an edge computing PIN, and at that moment in time, you need to make the software available to service that that message and do some computation, store some data, whatever it is you're doing in the software layer. Well, today's architecture doesn't do that, right? It presupposes that you're going to provision the infrastructure in advance and make it ready for that to happen. And serverless is kind of a step in that direction, right? That what Amazon has done with Lambda and others have done, Azure, Google Cloud Functions, Azure Functions, et cetera. But that only works in the cloud. So what we do is we make serverless work anywhere and everywhere, and we've paired serverless computing, the idea that software can run instantaneously, with the idea of serverless data storage. And by the way, I do think that serverless is like the worst name in history, because everything has a server somewhere. But this idea that developers are free from having to worry about the infrastructure itself, and their data and their software shows up anywhere and everywhere that it needs to be. And so this vision that Autonomy has, that digital infrastructure is the foundation, like what Jeff said earlier of, it's like when Eisenhower said, look, we're going to build interstates now because this is ridiculous. Like we need this stuff to move things around the country. This is the same, right? It's that level of infrastructure investment where we need to make sure that computing is like truly a utility, and that it's close. Yeah. And we didn't talk about this, but the driver for all this really is data. It's two things: the need for speed, so that's low latency stuff, and then the size of data. So even if you don't need something to be really fast, probably you want the data, and the data is very large. And so when my partner John and I started EDJX, we calculated on the back of a napkin that there was something like between 50 and 80 zettabytes of data stranded at the far edge in the IoT ecosystem. And that's just the 10% of data that's out there that's usable. And so that's, as I like to tell people who don't understand what a zettabyte is, 1 zettabyte is like the city of Manhattan replaced all the skyscrapers with 1 terabyte SSD drives, and that's what a zettabyte is. And so it's like between 50 and 80 cities of Manhattan of SSD drives worth of data that's sitting there right now that you can't backhaul because the network capacity isn't sufficient. And when you realize then that data is growing at a 35% plus CAGR, okay, then very quickly, 5 years in, you get to a 270 or 300 zettabyte shortfall. And that's why you're never going to backhaul that data to the cloud. That's a non-start. That's ridiculous. You're never going to have the bandwidth or the computing on the cloud side to do that. And the other thing we realized with Autonomy was like, we have to do this in a way that is sane environmentally, and resource efficient, and we need to take advantage of infrastructure that already exists. Yeah. If we do all this net new, we're going to destroy the planet, by covering it with computers. We can't do that. We have to have a circular supply chain and economy that leverages existing resources. And that's another area where our vision and Autonomy's vision just really gelled immediately. Let's cover the planet and computers, but let's do it in a way that's sane and efficient.
Yeah. Thank you, James. Yeah, I think all of this for our listeners' point of view, it just cements the fact that technology is advancing so drastically quick. I mean, you talk about Moore's law earlier, right? And I think what I'd be really interested to know a little bit more about is how we build out the world of autonomous things. Examples of this, including healthcare, life sciences, particularly Vision Zero for people that aren't aware as well. So it'd be interesting to know, how we move on from this and what your guys' thoughts are on that.
Well, I think the big focus is just education first. I mean, I think when people, we kind of use the example, before Eisenhower said we finally need to build highways, people were coming up with bigger engines for cars or bigger wheels or more wheels, or, I mean, it was just like they looked at the problem right in front of them, which was the ruts in the dirt roads. And then finally Eisenhower said, you know what? Asphalt and concrete will solve this problem. And we're now looking at, like, all the autonomous car companies from Silicon Valley are basically saying, we need more LiDAR, we need more radar, we need more cameras. They're looking at it from the vehicle standpoint versus the infrastructure. And once you start to build the infrastructure, the inverse happens, where you're able to effectively meet Vision Zero standards. You're able to be able to detect the surroundings and now feed that back into the car versus the car having to be self-aware of everything in its life. I mean, and the other funny thing about this is the infrastructure is already there. I mean, the ITS cabinets, I mean, people are very surprised when I tell them, drive down the street, and every single time you stop at a four-way light, look around to the four sides, and you're going to see a silver box. And usually, 2 days later, they'll call me or email me and say, I can't believe how much infrastructure is already deployed. And well, just think of that infrastructure being converted over to PINNs, and then you understand it's something that can actually take place very, very rapidly. And I'm just going to when your question about EDJX, we were very thankful that we discovered EDJX at the time we did, because we had just come off of the back end of a previous software company where our software was being used in 195 countries, executed almost 1 million missions. And the whole goal was to take massive amounts of data off these little tiny SD cards, somehow get that back into the cloud, and then leveraging Kubernetes instantiation of have thousands and thousands of Kubernetes clusters processing data. And when we realized that PINN was going to be required to densify the edge, the nightmare in our minds about having to manage Kubernetes at the edge literally scared every single engineer that was thinking about how we do this. And then come to find out there was already a solution that was extremely well architected to address that challenge.
Yeah, well, I mean, it sounds like a really good match, doesn't it? Like almost a perfect match that you guys met each other and were able to do this together. But surely some really exciting things on the radar. I mean, one of the things that I'm curious to hear from each of you is the trend or technology you're most excited about right this year. What is coming out? What is gonna change the game, as it were? James, do you want to start? What is it that kind of is getting you really enthusiastic about this year?
There are so many trends in play that are all coming together to make this edge thing happen. And so I'll run down a list and say, in the United States, things like CBRS and neutral tower, which neutral towers are also a thing in the UK and Europe, that's making it possible for new entrants to come into the wireless market and to provide enhanced services over just what traditionally the big and large telcos are doing and thinking. So this idea that we're going to get more innovation as a result of that, because more eyeballs working on the problem is a good thing, right? And I'm tremendously excited by that sort of family of technologies within the 5G space. Of course, 5G infrastructure build out is happening, and tremendous investment going to that, and definitely speed, better speeds and feeds are good. More coverage is good. All of that, ubiquitous networking is necessary. I think for us, what I'm most excited about are some arcane things in the the areas of distributed systems. And as I mentioned, we're peer-to-peer, and I think peer-to-peer is going to kind of have its second life now, its second moment. If you go back all the way into peer-to-peer, sort of flourished in the .com bubble as we were sharing music and files, with stuff like Napster and Newtile,
LimeWire,
and then Apple came out and said, hey, we're just going to make it so you can download whatever music you want, and it's all legit. You don't have to pirate music. And then peer-to-peer sort of died out a little bit, and the sole survivor there was BitTorrent, which had its it's space, it's niche, serving big files and as a distributed system. And so BitTorrent really was ahead of its time as a technology, and they figured out so many things that are now relevant in this era of distributed systems and distributed ledger, and I hate to use the B word, but blockchain, because I think that distributed ledger and blockchain in particular led to a rebirth of peer-to-peer, but it really is the edge that's going to bring it into its own. And so there'll be, over the next few years, you'll see we won't be the only ones. There will just be a flourishing of peer-to-peer distributed systems and new types of data networks and all of that. So that sort of umbrella of technologies, obviously I'm very closely wedded to and very excited about, but I just want to emphasize that it's a huge thing that's happening. It's not just us. There are lots of people looking at and inventing things in that space.
Yeah, fantastic. I'm actually looking forward to it. I was a big P2P fan, and not just for the free music, I've got to add, right? But it's not.
Go ahead. Sorry.
No, it's fine. It's nice that this is coming back, right? And I think that kind of control, that uniqueness that you have about it, as opposed to it being centralized. The whole decentralized movement for me is exciting, and it's transcending, multiple industries right now. And dare I say it, the dreaded B word, right? So it's really interesting.
And I'll point out just one more, that's in that vein, and that's WebAssembly. And WebAssembly is taking off. It's starting to have a moment. And what WebAssembly, for users or listeners on the podcast who may not be familiar with WebAssembly, what it is a new take on the write once, run anywhere model of computing. So, Java really and JavaScript really delivered that vision for the last couple of decades, right? This idea that you could write a program in one language and then target it for this runtime that would run on any operating system, and you didn't have to worry about the differences between OSs. Well, WebAssembly does that, but the code that it generates is very close to machine code. And so the consequence is that it's very high performance when compared to other technologies like JavaScript and Java. And you also get really fine-grained controls over what the code is doing. And so you can run untrusted code in this this runtime that it isn't a container per se, and it's definitely not a virtual machine. It's something lighter than either of those, and something that can run instantaneously. And so that you get this really high performance virtualization and security layer that didn't exist even a year ago. I mean, it's brand spanking new. And so that area of tech, tremendous brain power, lots of smarter people than me are inventing that area of tech. We're a consumer of that tech because it makes sense to put it makes sense to put WebAssembly on the server side, out there in the world, so that people can write and then target WebAssembly as the runtime, and their code can run anywhere on any type of hardware.
Yeah, no, thank you for that. Yeah, I mean it's useful for our listeners to hear about this bleeding edge movements, especially in software development and what have you, because it's going to affect everyone. It's going to be the flavor moving forward. Jeff, I'd be interested from your points personally, and that of obviously of the Autonomy Institute as well, for trends this year.
Well, I think this year the most exciting thing that I think we'll see is Open RAN becoming a thing, and solidly deployed. Because I think I really liked DARPA put together a video a couple years back talking and helping explain how the RF networks have to be treated very differently than we treat them now. So I think we're finally going to see Open RAN become a thing. I'm hopeful that by the end of the year, the U.S. will reclassify broadband at 1 gigabit or greater, not 30 down and 5 up, which I think is absurd. And from a standpoint, by the end of the year, we believe we'll be fielding autonomy, not going to be the autonomy that people expect. It's going to be things like lawnmowers automatically maintaining grounds across the city of Austin, rovers delivering pizza or groceries to people's very specific neighborhoods' houses, and most likely see small drones performing routine tasks on a daily, if not hourly basis. So I think all that can happen this year.
Yeah, I think, thank you so much for that. The drone thing for me is really interesting because we've not yet seen out and out or wide use of commercial use of drones, right? A lot of it has been hobbyists, etc. There's been lots of talk and there's been lots of reports of drone technology, but, having brands and corporate businesses using them for logistics or food delivery or what have you, that transition step would be a really interesting one.
A huge one, and the only way, the reason being is if right now it has to be a one-to-one relationship between a human and the drone, or in a lot of cases when you see Google Wing delivering a packet to somebody's house, what they don't understand is they just effectively are demonstrating how they can actually spend $150 to deliver a piece of fruit or something to the house because they have to have 5 to 10 people watching the drone fly from one place to another. So with the right sensor network, the right edge compute, the right open RAN networks, we're going to see a explosion of enabling technologies, and we'll finally move past the currently number one autonomous robot in the world being a Roomba vacuum. So we'll
it would be nice. It would be nice to do that, right? So
is the Roomba a vacuum? I thought it was a cat transportation device. That's how our cat uses it.
Well, yeah, hopefully. That would be a lovely point as well. On a serious matter, what you guys are doing collectively within your businesses is really, game changing, right? I'm trying to think of a better word, but it's game changing. So it would be lovely, perhaps in a year, 18 months time, maybe come back on the show and we can talk about what you've done. From this point, how the PINN has changed things, what the developments are from that point, and what's the next steps after that, because it's clearly a powerful force going on here.
Would love to. Yeah, hopefully we have tens of thousands of PINNs deployed, and we'll be coming to you live from the Cayman Islands.
Yeah, on the yacht, right?
Yeah, from the boat.
Absolutely. I hope you still have the Harvey Keitel poster behind you as well. I feel quite. I saw it first of all on your wall, and I thought you've got a picture of Mr. White from Reservoir Dogs, and it's Mr. White doing the podcast. I thought, did you put that up especially? That's quite interesting.
He's actually, that's the Harvey in Pulp Fiction as the wolf.
Oh, I see. Okay, I got it wrong. All right.
Yeah, one of my employees gave me that several years ago because he described me as like being like the wolf, like as the CTO of the company. And he's like, you only show up when there's a problem and then you fix things and then go away. You're like the wolf in Pulp Fiction. And so he gave me that.
But that's the right thing. That's what you'd want, right? You're to fix it. You come in, you fix it, you go, and
Yeah.
All right.
I decide who's on brain detail, and
All right, gentlemen. Thank you so much for your time. It's been a pleasure, honestly, meeting you both here on the show.
I appreciate it. I'm looking forward to the interview next year.
Yeah.
Talking about some exciting things.
Yeah, me already. All right.
Can't wait to come back. Thank you so much for the time.
All right, you're very welcome. Thank you.